going to prove a Pythagorean theorem using a manipulative way. So the materials are any piece of papers, a scissors, a pen, and a ruler. So first step, using a piece of paper, it should have been a square, okay? So if you form already a square, you have to fold this in this way. Okay, that is one fold. Okay, fold again for the second time. Fold again for the third time. And last fold. So we have 4 in all. Okay. If you notice, we have a small square. And after that, we're going to open it and return it to its original form. Okay. Here we go. If you notice, we created some lines in small squares. And the area of getting the square is s squared, right? Okay. So you count how many square we have here. 1, 2, 3, 4. So since we have already 4 here, so we have to square 4. Okay, so 4 squared, that is equivalent to 16. So overall we have 16 squares. Okay. Now in Pythagorean theorem, it states that the square of the hypotenuse is equal to a squared plus b squared, and a is considered to be the shorter leg and b is the longer leg. So using our figure, we have to create a triangle, a right triangle. Okay, so this is what we are going to do. We fold in this way. Okay, so we got 1. Fold another 1. So second, 1, 2, 3, and 4. Okay, so we already fold this and we have 4 right triangles. Okay, and in order to visualize this more, we have to use the pen and the ruler to make this 4 right triangle. Okay, if you notice, I am making a right triangle. We have to do the same thing on the other. Okay. Okay. Here we go. We have 4 right triangles, and we have to label this one as, consider this as our hypotenuse. Okay, so we label using the pen. Hypotenuse, and we do the same to the other triangles. So H, H, and H. So that is the hypotenuse. This is the opposite of the hypotenuse is the longer legs. So the opposite is here. So we label this, and so with the other triangles as L, as to be our longer leg. Okay. So the last side would be our shorter leg. We will label this at the same time the other side of the triangle. Okay. Here we go. We have our triangle labels as hypotenuse, and we have the opposite side, the longer leg, and the shorter leg. And in order to prove that c squared is equal to a squared plus b squared, so first we have to prove the hypotenuse. Okay, if you notice this side, this is the hypotenuse, so we have to fold this. Okay, fold the hypotenuse. So after that, we will do the same to the other triangle. This one too. Okay. What have you noticed? We form a square, and the area of getting the square is s squared. And since this is our hypotenuse, so we have this h squared. So we already proved the c squared. Next is we have to prove that it is equal to a squared plus b squared, which is the shorter leg squared plus longer squared. So we open this and return it to its original position. Okay. So if you notice in this side, this is our S or the shorter leg. So using the scissors, we have to cut this area. And so with the other area of the shorter leg. Okay, after that, we have to fold those area. Okay, we will fold like we did to the hypotenuse. Okay, but we have to remain this side. If you notice, when we fold the three shorter legs, that is equivalent to the others. So we just have to remain this one. And if you notice, we have these longer legs. This is now our longer leg, so we have to retain that one. So we also fold this area at the same time this one. And so with this, and cut again because this is our squared, right? Okay, so this is now our shorter leg. What have you noticed to our shorter leg? It forms a square, and the area is s squared. So we got already the a squared. How about our longer leg? Absolutely, it also forms a square with an area of s squared, or we can have this as l squared or the b squared. So if we add the area of our shorter leg and the longer leg, so we can come up with a squared plus b squared. And that is equal to our c squared, which is the hypotenuse, right? So the one that we have pulled. So we have a squared plus b squared is equal to c squared.
Good day, I'm Brian Franz Agustin, and I want to show you how to prove a Pythagorean theorem. So let's have a right triangle. So we all know that the formula of Pythagorean theorem is a squared plus b squared is equals to c squared. So side A, side B, and side C. So we should put the C in the longest side of the triangle. So now let's make a four triangle. So now we have our four triangle. So let's put the C in the hypotenuse side or the longest side. So let's arrange this to become a four triangle or one square. So let's put this here, B and the A here. So our fourth triangle makes four square or one square. So we all know that this side is C, 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 or the hypotenuse of each right triangle. So the formula of a triangle is equals to A equals to S squared. And as we know that we have A and B, so let's add the two because we have the same sides So A plus B squared. That's the area of a square. So now, let's solve this to this fourth triangle. So, for the area of a triangle is equal to 1/2 of base times height. And there are four. So, plus 1/2 times base times height plus 1/2 base times height plus this portion is whole square plus c squared. So now the area of is equal to 2b times h plus c squared. So as we label this, the base and height is a and b. So it's equal to 2ab plus c squared. So now let's copy this. Area of a square, a plus b squared is equal to 2ab plus c squared. So multiply this, a squared plus 2ab plus b squared is equal to 2ab plus c squared. To eliminate this 2ab, let's use the additional property of equalities. So a squared plus 2ab plus b squared plus the negative 2ab is equal to 2ab plus c squared plus the negative 2ab. So it's equal to 2a squared plus b squared is equal to c squared. So this is our Pythagorean theorem.